In this video, we'll look at a delete operation on a doubly linked list. There are two cases for deletion, just like a linear linked list already we have seen. So two cases are there, that is deleting first node or deleting from a given index, deleting a node from a given index. So deleting first node is a special case and deleting any other node is a common case and it's another case. So first we will see how to delete first node. What are the steps required? Say I want to delete this node. After deleting this node, this should become the first node. First is pointing here, so first should move to the next node. So I should move first. But before moving first, let us take a pointer P upon this node and then move first. So first we'll move to next node. So take P upon first and move first to next node. So this is the next node. Now, with the help of pointer P, take out the value if you want, take out the value and then delete the node. So this node is deleted. And first previous, this should point as null. And while doing this, you should be careful whether first is really pointing on some node. Suppose this was just a single node, then first will become null. So you cannot make first previous as null. There is no first previous. So I have to do this little carefully. That check whether first is not null. If not null, then make it as null. So first previous, make it as null. Let me write down the steps. First step is bring P upon first. So P upon first. Then move first to next node. First assign first caps next. First assign first caps next. Then take out the value and delete the node. P's data is taken in X and delete the node. Node is deleted. Then when this node is deleted means this is gone, right? So I should make this as null. So that I should check if really first is pointing upon some node. So if first means first is not null, then the same line I will write down, make first previous as null. So I have to make this as null and remove the link from here. First previous is made as null. So this is made as null. So these are the steps required. And these are constant steps. 1, 2, 3, 4, 5. Few steps are there. So 5 steps. So the time taken will be constant. Now let us see the procedure for deleting a node from given index. Suppose I want to delete fourth node. Position is 4. Suppose position is 4. How to delete that node? Let us see the procedure. If I have to delete fourth node, then this third node should point on fifth node and fifth node should point on third node. Then this node is not reachable. You can delete the node. So for this, I have to modify two nodes and delete one node. Delete fourth node, modify fifth node and third node. So two nodes I should modify. So total how many nodes are involved here? 3 nodes are involved. Then how many pointers we need? 3 pointers. Is it possible using single pointer? If I have a pointer here, yes, I can say next and I can access this node. I can say previous and I can access this node. So let us do it using single pointer. So where I should have a pointer? I should have a pointer upon this node. So let us bring a pointer P from first to that node. So if I have a pointer P and bring it here, so how many times I should move it to bring it on fourth node? 1, 2, 3. So that code I will write down here. P is upon first and move P for position -1 times so that it comes here. So with this for loop, P will come on to this node. Now what are the links I have to modify? P's previous, its next should point on P's next, this node. So this is the address. So P's previous next should point on P's next, this node. So P's previous next should point on P's next. Then this link will be pointing on this one. So if you come from here, 6 sends you to 9, 9 will send you to 3, 3 will send you to 2. So I'm not able to reach on this node. So one link is removed. Now next link I have to remove. P's next means this nodes. Its previous should point on this node. So that is P's previous. So here I should write on the address of this node. So the address of this node is available here. So it means this value should be copied here. So P's next previous. P caps next caps previous should point on P caps previous. So but before writing this, one important thing. If suppose there is no node after fourth node, fourth is the last node, right? There is no node on the right side. Next, there is no node. Then I cannot access it. It's an error. If you try to access nulls next or nulls previous, that's an error. So I can access that node if it is present. So I should check the condition whether P's next is there or not there. Means is it null or not null. So if it is not null, I should do it. So first of all, check P is next. Is it null or not? If P is next, then P is next previous. P is next previous should be assigned with P is previous. This node's address that is present here. So assigned with P is previous. So this link will also modify. Now this node P is not reachable. From here also you cannot reach P. From there also you cannot reach P. From 5 we are directly coming on 3. From 3 we are going directly to 5. Now this node can be deleted. So take out the value and delete the node. X assign P's data, take out the data and delete the node. Delete P will delete the node. So this is the procedure for deleting a node from given position. So we have seen both the procedure, deleting first node, deleting a node from any given index. Now a little bit of analysis. How many extra pointers required? Just one extra pointer, P. In both the cases we have used just P. Here also we have used P, here also. If you read the code, you don't find any other pointer apart from P. Second one, analysis. This was constant. Now this depends on how much P is being moved. So this for loop, it depends on the for loop. This will move P. So it depends on the position. If the position is last position, so the time is maximum, say order of n. Or else if the position is second position, this node, then the time is minimum, that is constant. Means this loop will not execute at all, just these statements will execute if you are deleting second node. So that's all about insert. Now a complete function and using it in the program, I will do it as we are used to with the previous linked list. Now similar way, I will combine these and I will write it as a single function.